theta, or mg sine theta. Mg sine theta is equal to ma. Mass cancels out. What will be the acceleration due to gravity? G sine theta. So if an object is sliding without friction, will be G sine theta. Which one is greater? An object sliding without friction on ice, or an object rotating? What is greater? 1 or 2/3? 1. So if the object doesn't have friction and the object doesn't have rotation, is 1/3 greater than this one. So what is the meaning? That when a disk is rotating, due to the rotation, 1/3 of the acceleration is lost into the rotation. So if this was sliding without friction, will be G sine theta. But if it's rotating with a static friction, will be 1/3 slower than an object sliding without friction. Why? Because 1/3 have to go to give rotation to the particles. And this is the meaning of that. Then, if we want to, this is the acceleration. If you want to find the acceleration, you find the acceleration. What will be the difference in the question I will give in the study guide, or multiple choice, or free response, if I ask, given an object rolling, what will be the change? You know, instead of a disk, I will give a ring, I will give a solid sphere, I will give any object rolling, and you just need to figure it out what will be the acceleration. The process, the same. This is the acceleration. What about if I want to find the coefficient of friction? You go back and you look for where is the friction alone. In which of all these equations, which are equivalent, is the friction alone? Because you want to find the coefficient of friction. Here is alone. You can find it here, but it's more complicated. I can see that here is alone. I already left alone the friction. So the friction is equal to what? What is the leftover here? M times A. Correct? If you want to find the force of friction, this is the force of friction. Except you have to plug it in here, A. What is A? We found it. So if you want to find the friction, the only thing you need to do is to plug it in here, and you find the friction. If you want to find the friction, will be 2/3 over 2, 2/3 over 2, let me just put the third here, G sine theta. So what is the friction? 1/3 of the mass, M is here. 1/3 of N G sine theta. This, which that said that the friction is slowing down the object with respect to the force of gravity by 1/3. So the force of gravity mg sine theta, you have to subtract 1/3 of mg sine theta, which is the 1/3 that is missing in the acceleration. That's the friction. But if I want to find the coefficient of friction, how can I find the coefficient of friction? What is F in terms of the coefficient of friction? Mu S, in this case, static, times what? Normal force. Equal 1/3 m g sine theta. Is that correct? And what was Fn on the inclined plane? Let's look at this. Fn minus mg cosine theta equal ma or equal 0? Zero because it's not moving along y. So since we have that the Fn is mg cosine theta, I replace here mu s mg cosine theta is equal to 1/3 mg sine theta. We can see that mg and mg cancels out, and we get that mu s is equal to 1/3 tangent theta. And this is the coefficient of friction. What will be the next question? So here is the way that we apply the Newton laws. What about if I want to find, using the Newton laws, V at the bottom of the incline? V at the bottom of the incline, I give H, or I give theta and delta X. How can I find V at the bottom of the incline? I will go to here. Here we have the equation of kinematics. Except linear motion. We want to find V linear. If you have H or delta X and theta, which of the three equations we use to find V at the bottom of the incline? First, second, or third? The second is, what is the second? The second said delta X equal VOT plus 1/2 AT squared. Did I say anything about the time? It's time dependent. So to which one I have to go? To the third, which is time independent. And the third is V squared, VO squared plus 2A delta X. Is that right? Assuming that the object started from rest, my formula will stay like this. And what is A? V squared is alpha over R, but we already found what is A in this problem. 2/3, so I come here 2 times what? 2 over 3 G sine theta. And what is delta X? Delta X sine theta? H. So 4 over 3 G H. V is the square root of 4 over 3 GH. This is the velocity of this object. My question is, so far, have you seen that we have 2/3 of what we learned before? Kinematics and Newton laws. What is missing in this problem? Energy and momentum. Right? So energy. I have to erase this